Hey everyone, you ever wanted to build your own video game, like completely from scratch? Well, today, that's exactly what we're going to do. We're using Python to build the classic game of concentration. Let's dive right in. Yup, this is the classic game of concentration. And you know what? By the time we're done here, you'll have built this exact game yourself. I'm talking everything: the board, the cards, the rules, even a timer. For real. Okay, I know that probably sounds like a ton of work, right? But here's the secret, and it's a simple one. You just break it down into smaller pieces. And that's exactly how we're going to tackle this, one step at a time. All right, first things first. Every board game needs, well, a board. We can't just have cards floating around in some digital void, so our very first job is to create the playing area. So that leads us to our first big question. How do we even draw this thing? How do we tell the computer, hey, I need a grid of face-down cards? And maybe more importantly, how do you even represent a grid in your code? The answer is something called a 2D list. And honestly, the easiest way to think about this is like a spreadsheet. You know, it's got rows, it's got columns. This structure is absolutely perfect for any kind of grid, whether it's tic-tac-toe or even chess. So for our game, we're going to store the entire board in a 2D list we'll call app.cards. Okay, so to actually get that grid on the screen, we're going to use a super common programming pattern, a nested loop. Basically, you have an outer loop that goes through each row, and then an inner loop that goes through each column inside that row. And at every single spot, we just tell the program, draw a gray rectangle right here. That's it. And here's the really clever part. This is what makes it all work. We're not just drawing simple shapes. For every single one of those rectangles, we're creating an object, a little bundle of information that knows its own position. And then we store that object right back into our 2D list. This is how our program actually keeps track of where every single card is on the board. Super important. Okay, so we've got a grid of gray cards. Awesome. But this is concentration, right? We need pairs of colors hidden underneath all of them. So the next puzzle is, how do we place those colors randomly onto our board? The logic here is actually pretty straightforward. We'll make a list of colors we want to use, red, blue, green, whatever. Then, for each of those colors, we tell the program to do the exact same thing twice. Find a random empty spot on the board and stick that color there. But hang on, what if the program randomly picks a spot that's already taken? We could accidentally write over a card we just placed. We need a safety check, and that's where a while loop comes in to save the day. This loop basically tells the program, hey, keep picking random spots until you find one that's actually empty. It's a simple little loop, but it's a super powerful way to make sure our code doesn't break. Okay, our board is set up, it's got hidden colors, but right now it's just a picture. How does the player actually interact with it? Right, the next big step is to make these cards clickable. Okay, this next part, this is the magic trick behind the entire game. So listen up. When we create the cards, we set what you see, their fill, to gray. But at the same time, we give them a hidden custom property. We can call it .color. And that's where we store their true value. The player just sees a bunch of gray squares, but our program knows the secret color of every single one. So, a player clicks somewhere on the screen. How does the program have any idea if they hit a card? And if they did, which one did they click? Well, Python has this really cool built-in function for this called onMousePress. The instant you click your mouse, it grabs the X and Y coordinates of your cursor. Our code then loops through every single card in our 2D list and uses this handy little method called .hits to basically ask each card, hey, were you just clicked? If a card says yes, boom, we found the one we're looking for. And this right here is where that whole hidden property thing totally pays off. Once we know which card was clicked, revealing its color is just one single line of code. We just say, hey card, set your visible fill to be the value we saved in your hidden .color property. And just like that, the card flips over. So cool. All right, we've got a board, we've got hidden colors, we can click the cards, we're getting there. Now we need the rules. This is the logic that's going to turn this interactive screen into an actual playable game of concentration. So the whole point of concentration is matching pairs, right? That means our program needs a short-term memory. It has to remember the first card a player flips, and then it has to remember the second one. So to do that, we'll create two new variables to keep track of this: app.firstCard and app.secondCard. So a player's turn is going to follow 4 pretty simple steps. First, they click a card, we grab that card and save it as app.firstCard. Then they click a second card, and we save that one as app.secondcard. Now, here's a key detail. Instead of checking for a match instantly, we're going to pause for about a second. This is important because it gives the player time to actually see both colors. After that little pause, a timer function kicks in and checks if they're a match. Okay, after that 1-second pause, it's decision time. Two things can happen. If the colors match, awesome. We'll change their borders to green to show they're a pair, and they stay flipped over. But if they don't match, we just flip them back to gray. Either way, the most important step happens last. We reset first card and second card back to empty. This gets us ready for the very next turn. Okay, we are so close. The game is totally playable now. The only thing left is to add the final conditions. How does a player actually win and how do they lose? The logic for winning and losing is actually super simple. For winning, the game just needs to check after every successful match, are there any gray cards left? If the answer is no, you win. For losing, we can just add a simple timer. We'll start it at, say, 30 seconds and have it count down. If that timer hits 0 before you find all the matches, game over.
And just like that, there you have it. By taking this big, kind of intimidating problem and just breaking it down into smaller, manageable pieces, the board, the clicks, the rules, you've built a complete working game from the ground up. Seriously, congratulations.
But honestly, the biggest takeaway here isn't just this one game. Think about it. Using a 2D list for a board, handling mouse clicks, tracking the state of the game with variables, these are fundamental building blocks. These are skills you can now use to create all sorts of other games. And that brings us to a final thought. Now that you know how all the pieces work, how would you take it a step further? Just think about it for a sec. What would you have to do to add a high score feature? What new variables would you need to create? And where in the code would you check to see if the player just set a new record? The possibilities, well, they're all yours to code.